Good morning. So we're actually going to be doing a tag team here session in 40 minutes. And sometimes we do live hacks. Instead, we're going to tell you stories and give you a chance to guess what some of these vulnerabilities were that we actually found, and then give you some best practices here. So I'm the Chief Mobility Officer here at Now Secure. So I've been doing mobile since back to the BlackBerry days when that's what ruled the world. Now BlackBerry runs on Android, so go figure. And with me is Michael Krueger. He's our pen testing lead, and he'll introduce himself when he comes up to show you stories. And Brian Lawrence is with us as well from our solution engineering team, runs that team in the marketplace. So we're gonna have a little bit of fun. They wound up sending us a bunch of shirts, so we'll give away some shirts. So this is your chance to get a false positive suck shirt if you can answer the question. What percentage of apps in the Google Play Store have a vulnerability? Pretty close. All right, so the answer is actually 85%. So we have technology that crawls the web, and so we've crawled the App Store. We've tested every app in the Android App Store that's testable in a remote fashion in a non-logged in way, and we found about 85%. So that gentleman over there gets his, one of you guys want to pick one. You want a shirt or socks? Socks, there you go. Oh, there we go. And then I was going to ask you this question. I already told you the answer. So about half the apps actually leak private data as well. We're going to show you some examples of this. So we very much believe in secure coding best practices. We have a development team that works with other developers along with security teams. And so we're going to kind of walk you through this journey. We work with a lot of Fortune 100 companies and other apps that you probably used. We took an Uber here this morning to help make sure that these apps are secure, right? And we've got capabilities to help you out. Now, to kind of get set the table here, I'm assuming most of you, if not all of your application developers, and so one of the things to think about when we think about AppSec is to really think about what's the adversary actually doing. And that kind of requires a different kind of mindset. And so when you sit with our pen testing team and look at how they work on assessments with clients over the years, it's really about looking at where the issues are and what could be exploited. The attacker is going to look at the application in terms of what does it do, how does it behave, what resources does it use on the device, what does it connect to on the back end, how does it connect to it on the back end, what things can I find. I know, by the way, it's just Java code, so I'm going to reverse it anyway as part of the process. And so that attacker point of view is often very orthogonal to how, as developers or application architects, we think about our application. So here's an example of an all too frequent pattern that we've seen in the marketplace, and these guys are going to show you four in a second. And so, you know, as an attacker, I'm going to download the app, I'm going to create an account, I'm going to surveil its use, I'm going to watch its behavior on the device. I'm going to go ahead and reverse it, which is really easy to do with lots of the tools that are out there. I'm going to manipulate it. So as part of the reversing process, I'm going to look at the code, I'm going to run it, and see what I can intercept, what I can manipulate in terms of interactions, and see what the inputs and outputs are on the device. I've got a network sniffer on it as well, so we can see what's going back and forth. I'm going to start harvesting PII because just about every app in the App Store is going to leak some kind of private data. There might be interesting things I can use. On occasion, it's things like user ID and password. I'll definitely map the back end and all the endpoints, right? And this is how they'll discover endpoints that are exposed. And it may turn out the endpoints they discover is their method of attack as opposed to anything in the application. All too frequently, we will find that an application has no hostname validation or cert validation, because those things are tough to do consistently in the right way. And what that actually means now is that I can now intercept the application. I'm going to redirect them to a phishing endpoint or what have you, and I'm off and running, harvesting credentials, stealing information, and all the rest. Some of the examples we're going to show you today look like this. You would be shocked at how frequently hostname validation failures actually occur. And so we've got a series of best practices for you to kind of focus on to think about how does the attacker get in the middle here as part of the journey. And so with that, let's get started with Michael. And Michael's got a couple of great stories to show you here. All yours.
All right, good morning everyone. So again, I'm Michael Krueger. A little background on me, I've got about 13, 14 years applied experience in mobile pen testing. I come from the Federal Intelligence. I came to Now Secure after that and been doing that ever since. So a couple of examples. All right. Number one, how many of you have mobile banking apps on your phone right now? Cool. So do I. I use it all the time. I love the convenience. So let's talk about a scenario with mobile banking. And just a reminder, everything that we talk about here, while we're not using names, every single one of these examples are real life examples that we run into on my team, on the pen testing team, every time that we do an assessment. So we're helping these companies actually correct these mistakes. So these are not just made up examples. These are real life things that we run into time and time again that we have to correct. So let's talk about the scenario here. You've got a bank app, initial configuration, you use your password, your username, you log in, and then you enable your biometric authentication. So your fingerprint or what have you, whatever that biometric authentication is, you do that. Why? Because you don't want to have to log in again. You use that app frequently, you just want to enter your fingerprint and go. All right, so at runtime, everything works fine, right? You're out at night, you need to, oh shoot, I forgot, I got to pay a bill, open it up, use your fingerprint, you use it. Great. All right, now, what if, let's take this scenario, what if you've got another user that gets access to your phone? So you're out at night, hand your phone to your friend. What if your friend actually enrolls another fingerprint on your device? What happens? Well, perhaps that other user can actually log into that mobile app, okay? So let's take a step back, let's talk about this again. So you've got one fingerprint on your device, it's yours. The mobile app is registered with that biometric authentication handler. Now I enroll, I take your device, either I found it, you handed it to me, however that scenario takes place, I enroll my own fingerprint, and now I have access to that mobile app or any other mobile app that's using that biometric authentication handler. Bad things happen. So let's stop. What is the actual vulnerability here? What broke down? What didn't happen? Anyone? That's correct. What else? That's also correct. All right, so failure to re-request that authentication. Whenever a new fingerprint or any new biometric identity is enrolled in the device, the number one thing that should happen is you should require re-authentication of all of those mobile apps. So there's actually a setting here, set and validated by biometric enrollment. All right, that's something that you should be using in this case. We don't ever want to allow the user to be able to log in after that new enrollment. That scenario happens time and time again. We actually heard about this in the news where people were being socially engineered or exploited at bars because they were handing over their phone to get a phone number, and the person was actually enrolling their fingerprint, opening up payment apps, and transferring money out of that person's account and into the attacker's account. So this is a real life exploit. This is a real thing that happens. All right, let's take a completely 180 and let's talk about an energy app. All right, so we've got a company that has a couple different apps, big energy conglomerate. They've got a couple of apps get installed on the device and they're sharing data between each other. How do they do that? Okay, well, common way is content providers. So what are they sharing between the apps? Well, they've got site information, lock codes, things that are probably pretty sensitive, access instructions. They're sharing it back and forth between the apps. Why? Well, one of them's an automatic door unlock app. The other is their master control app. They're sharing data in between. Well, a couple of things aren't happening. I'll tell you a couple, and then we'll ask, what is the general vulnerability here? So they weren't encrypting data. Okay, well, that was bad. They were sharing data between apps, they weren't encrypting it. So any app or malware can access anything in these content providers right now. That confidential information was then found on the dark web. So again, lock codes, personal information, access instructions for energy company style locks, procedures, access environment, all of that. And again, bad things happen. So generally, what was the vulnerability here? What went wrong? I'm sorry? That's correct. That's exactly it. They weren't verifying who was accessing the data. So failure to properly use content providers and set the permissions. Set proper input validation as well. So in this case, it was as easy as running an ADB command to access that content provider externally from the app at all. So we didn't even need a mobile application in order to pull that data. We could do that programmatically, but we could also do it from any application on the device. Any application could query that and get its entire database. So again, usernames. I've seen passwords in this. I've seen, again, lock codes, access instructions, a whole wealth of information, and it's just a breakdown of that authorization. Yes, question? The question was, if it's sensitive data, why is it included in the APK by default? Well, good question. It shouldn't, the data that they were handling shouldn't have been handled in that way to begin with. They should have been storing it on a back-end database. They should have been reaching out, getting that data over an encrypted channel, pulling that back, and then communicating either easier access instructions, or honestly, the apps really in this case didn't need to talk to each other. They were just using the central repository app to pull all of the data down from their network backend and then exchange internally, whereas those apps actually individually could have communicated with their backend securely. So it was just, when they built their original infrastructure, they built one app and then they built off of that app and off of that app. So rather than re-engineering their entire architecture, they built off of that kind of initial platform. Good question. And I should have pointed out, for every single one of these, we do have some additional resources. Again, come visit us at our booth later today if you want to talk more about any of these. These are a couple short cases. All right. And that's all for me. Any other questions before I leave? And I'll hand it off to the next Brian. All right, thank you.
All right, so I wanted to talk, my name's Brian Lawrence. I run our solution engineering team at NowSecure. It's our job to go out and help kind of our tab A fit into your company's slot B. So we do a lot of integration work, and we're typically the tip of the spear. We're taking those first looks at people's applications. So wanted to talk about a couple favorites that we'd found. First up is, who's ever ordered food online on their phone? Anybody? A couple years ago, we did a really cool demo, Talk Like This. One of our researchers opened up an application, reverse engineered the ordering protocol, and had pizza there by the end of his talk. So that's the kind of the perspective that we're taking. So this application was allowing people to log in, and Brian spoke earlier about hosting verification being a thing that we find a lot in the wild. How many people here started in web apps and then moved to mobile? That few, really? Wow. Okay. One of the things that in the web app world you don't have to do is hosting validation, because Safari, Chrome, Firefox, the browser will do it for you. So it does that check, and so typically web app development is only going to be looking for that valid certificate provider. Who knows how many people in this room can get a valid certificate? Shout it out, anybody? Everybody. That man gets a shirt. Anybody with $300 and a website can get a valid certificate. So if you're only checking that one piece, I can own your traffic. So logging into this mobile application, first thing we got is your username and password. We can see that right away. We've got you there. But that's not enough for us. So when this application logged in, it actually pinged and looked for the updated version of the application, because you guys, developers, are working hard, adding new features all the time, hopefully driving new revenue. You want those features to be used. So the app pinged and made sure it was the up-to-date version. If it wasn't, it asked people to update. Inside that update was a deep link to go to the Play Store, seemingly harmless. Except I, as the attacker inside that network traffic, can change that deep link. And we'll see how fun that is. So you're ordering food, you give us you give your credit card information. I've got that too now. You complete the order. One of the interesting things that happened with this application as well, when you completed the order, it sent you a bunch of promotional items. Hey, we love that you ordered now. Come back. We'll give you 5% off or whatever that number was. Did it in a zip file. One thing I'll say: don't use zip files. Because we could see and modify that zip file in transit, we stopped it. We can add executable code into that zip file. It hits the device, it automatically extracts. Not only could we change the code of your application, I can actually change code on the device. So this one was a great example of just layers, like one little tiny thing, not checking a host name, just stacked into a pretty serious attack chain. And then, so with that deep link, we actually sent ourselves $10 in Venmo too. So we changed that deep link to a deep link. Instead of going to the App Store, it went to Venmo with our user information and sent us $10. So that was a fun demo. Lots of bad things obviously can happen with this. And again, it's those little tiny things that unfortunately a lot of times, like your static testing, code testing, isn't going to be able to see. It's just a little bit different. It's one of those nuances of web versus mobile applications. So, shouldn't be scared to order fast food in general. We were able to help this company fix the problem. But just something to think about as we're going through talking about these flaws. It's usually just little things stacking on top of each other. So issue, just to recap that, deep links are dangerous. They have to be protected. Host name validation is very, very important. That's usually where we'll find most what we call man-in-the-middle attacks. So this is something, has anybody heard of CVSS? Couple? Basically, it's, in the security world, it's how we talk about risk. So it's a calculator. There's 8 different buttons that you push, and it's, how hard is this exploit? How easy is it to get the access for it? How bad is what we're doing once we get the exploit? The CVSS score for this vulnerability, it's a number. 1 is it's okay, to 10, which is throw your phone in a microwave. We did the CVSS score for this was a 9.8. So this is something where very, very serious issue, had to be remediated very, very quickly. Next was coupon apps. So everybody's probably seen applications out there. They'll let you generate coupons and say, okay, I want to buy clothes from this website, and they'll provide coupons, encourage you to go to certain places. So we were able to log in. That was secure. They were validating the host name. Everything was good. But what we found is when we were searching for coupons, everything was being held locally. So they were actually, when you were searching for the coupons, everything was being done on the device. We weren't seeing a lot of network traffic going in and out. So we did a little more digging, and we found that all of the logic for performing any coupon generation was being done locally on the device. So we could actually change whatever we wanted. So that 5% coupon, if we added a 0 to that in the network traffic going back, we just got 50% off instead of 5. One of the lessons that a lot of times we have to educate people about is your app is public. Your code is public. Everything that you put out into the App Store, we can see. Everybody can see it. This isn't necessarily a bad thing, but it's definitely something to consider as you're putting things out into the world. So we were actually able to create new coupons. We were able to change coupons that already existed, and then we just pushed it back to the back end, and suddenly we had ourselves a new great coupon. So keep things off the device. Everything is public. In the App Store, it's actually a fun live demo. We'll do it at security talks. Is you can actually go from a compiled binary, 1s and 0s, to full Java code in about 5 seconds. It doesn't take much. There's open source tools out there. It's very, very easy to do. And to fix this, it's fairly straightforward. You have to do input validation. You have to make sure that the data you're taking in, don't trust anything. That's another big thing we're talking about in the security world a lot now is just a zero trust policy. You have to assume that someone is trying to break into your application and work from that premise as how you handle your data. So yeah, with that, I will turn it over to Brian, who's going to talk about all of the apps that we've looked at.
So our goal today was to give you some examples, and we chose these 4 because they're prevalence, right? Each of them has some set of patterns underneath them that have to do with interacting on the back end, how much IP is on the client, and so on and so forth. So when I was talking to Google a few weeks ago about this presentation, they asked me to go ahead and include one of our large data dumps. So we continuously scan the App Store. We have some in-depth analysis tools that we use that are both open source and commercial. And so I pulled the last 200,000 apps we've tested from the Google Play Store to get some statistics. And so it was kind of interesting. Right now, I will say that if you look at iOS apps, you get similar patterns. Your mileage may vary by operating system. So huge amount of data leakage. Most of it's on device, some of it's over the air. And sometimes those are simple coding failures. You know, one of the most interesting things about data leakage is that could actually be the third-party libraries you're using. Things like ad libraries that you might be using for your business to monetize are notorious for leaking PII, right? And so as your organization, especially if you're global, if you're gonna have to deal with the California Privacy Act or GDPR in Europe, that gets really bad really quickly. It's not your fault, your team wrote the right code, it's a third-party library, so watch out for ad libraries there, for example. From the web side, there's still cooking that occurs on the device with mobile apps, and we find a lot of cooking issues still occurring there. That's a simple bit to throw. So we got some easy guidelines around that. We find an incredible amount of world readable, world writable, right? We were with a group last week. We showed the gentleman, some results from the app. He said, there's no way, we never do that. They went and did some code tracing. They discovered at 1 second, one of their developers opened up and made something world readable, world writable to overcome an issue they had in trying to create a feature in their application, and they closed it again. Well, because they'd only ever statically scanned it and they never actually run any kind of dynamic testing, they never realized that would happen. We were actually able to extract some highly valuable information for this particular app, which is a purchasing application for a company in Europe. Don't turn on JavaScript, right? That is an attacker's dream to get into your application, and so we find about a third of the applications do turn on JavaScript. It can be a great way to add features and reuse code from somewhere else, but again, because you got that full operating system, you don't have the protections on the server side that you normally get with JavaScript. Dynamic code loading is another challenge we frequently see, right? You may be pulling down code for lots of different reasons. Be very careful in how you do it. Make sure you're validating front end and back end. Make sure you're re-authenticating if necessary. Make sure you've got other validations when it comes down that it's the original package that you intended to have come down. Dynamic code loading on its own is not bad, but we often find mistakes in and around it. As Brian said earlier, downloading zip files is an attacker's dream and your worst nightmare, so stay away from that as well. So then on the right-hand side, out of that bundle, we found 9,400. That's actually a lower number than we found 2 quarters ago, who actually had those network validation failures like we showed today. And there were actually about 1,100 applications that had active RCEs in them. If you wander past our stand out there, you'll see a cable company. A company that's up on the board, yeah. Hope you don't use the cable service, but we see a cable company that's got some bad things in it as well, and one of their sister applications has an RCE in it. So the stats are there. So the question is, what do these guys have in common? What do the yellow have in common on this list? It's a real hard question. They're found through dynamic testing. What we've seen in working with organizations typically is you're going to use some sort of static scanning tool. You as a developer may have it in your IDE. Security team may have it. You may have it plugged into your Jenkins environment, what have you. Static helps you find coding errors, right? There's lots of false positives and everything else. But the biggest gap tends to be around dynamic. And so when we look at all of the hundreds of tests that we run on these thousands of applications, what we tend to find is a very high proportion of applications have never been dynamically tested or poorly dynamically tested. And so what you can see here is that the preponderance of the issues we find are actually found through dynamic because they made it out into the wild. Hopefully you're using static and you caught most of this stuff. You know, the cookie issue, your SAS tool should remind you of. The JavaScript issue is one you should know. Your SAS tool isn't going to tell you don't use JavaScript. So think about that. So a couple of best practices. When you think about your application, think about it like an attacker. We publish this mobile attack surface every year and we update it. It's a big long laundry list of all the bad stuff that's currently being used by the bad guys. And so clearly there are exploits around code functionality itself. You want to make sure you're protecting yourself there. But data at rest and data in motion become ways that attackers are really harvesting information and redirecting activities like the examples that you saw today. And you don't want those things to happen to you. So, you know, if you're thinking about the traditional web world and testing with a web mindset, this is all you're really looking at, because this is all that's really in common between web and mobile, from an attacker side and from the mobile side when looking at the applications. And so if you try to use web tools or static tools, they may not cover you. That's why you need to have dynamic testing that will catch all these other things. And there's open source tools, there's commercial tools, what have you. Just make sure that your application security program somewhere, somehow has dynamic testing in it, whether it's got a human doing it or whether you're using tooling to get there. And so what that then allows you to do, and we've got a checklist that you can see of what kinds of things are found through dynamic testing, is it really captures what's going on by running the application. The gentleman we were with last week came back after about 8 hours of arguing with us and said, how did you find that? You must have been tracing the application. We're like, yeah, that's what dynamic is. This company's building commercial apps for companies in Europe and has never performed a dynamic test on an application ever for their commercial clients, right? So work with your security team and make sure some of this is built into the process of how your applications are actually getting built. So a couple of great summary best practices, and then we'd love to take your questions. So first one is partner with your security team, right? Most of you are on the development side. Security in most companies is there to try to help, so leverage them the best you can. Some of our services leaders say that they do marriage counseling. So in many instances, we will come in and help the two teams kind of work together, form a common language, and so on and so forth. Be sure that the user stories that are coming out of product management or wherever your application requirements are coming from actually address security and privacy in some way, right? These are both functional and non-functional requirements. It's astounding how many audits we do and we discover that there are just no security requirements at all coming out of the business side. Now, if you ask a business owner, do you want to be on the front page of the Wall Street Journal after violating GDPR and getting a $150 million fine like British Airways, they're going to say, no, I don't want that. But the business owner doesn't even know what to put in there to protect themselves. So with the engineering team leads partnering with the security team, make sure there are requirements in there that get documented by PM. In some companies, PM, there's actually a product manager or similar type project manager who's got some security responsibility, and many others, it'll be a security person working embedded inside the development team to help do that. Take the time to read the Google resources. You'll notice a number of the links here were around secure development. Google's got a ton of resources and continues to grow them. We refer clients to that all the time. And continue to work within that. Their blog posts as well are very useful. Learn what threat modeling is. There was a session yesterday that I was in where the gentleman was talking about threat modeling. If you haven't been exposed to it, find a mechanism to learn about it. I've got a link to a resource here coming at the end. Threat modeling is really the practice of looking at your app and what are the risks in the app and then determining which risks you need to control for from that perspective. In many instances, people don't really understand what risk means, right? And they don't understand where the threats can come from on a threat modeling basis. There's classes you can take for this. There's content you can read and download. It may not be the sexiest thing in the world, but if you're building code, you want to make sure, especially if you're a big name business, a publicly traded company or what have you, you just want to make sure you understand this enough. The benefit of threat modeling also allows you to be practical, right? Because threat modeling will lead you to questions like, is this a low risk app? Does it have any IP? Does it have any capabilities to perform an action that could harm a human or harm the customer or the user and so on and so forth? It may actually turn out that your app has such a low threat that you don't have to worry so much about the security. So we work with organizations to create a tiered model, and in constructing a tiered model, it's the tier one big, high-end applications that maybe have your IP in them, that your customers or your primary users are using as customer information, what have you. Of course, you want to do everything you can there. But for others, you don't necessarily have to go that far. And then make sure dynamic testing is part of where you go. What's kind of interesting about this is having come from the web world into mobile, like many of some of you did, I guess we expected more people to raise their hands, we usually get that, is in the web world there's a lot of protections built into the browser and into the back end, and you've got a security and network team that's built a perimeter around your infrastructure. In the web world, that's great. In the mobile world, forget about it, right? It's the Wild West, it's a zero trust device, lots of bad things can happen. In the web world, static testing covers an app to a pretty high degree running in a web browser. But in the mobile world, as we showed you earlier, it's actually the opposite. Dynamic finds more of the actual vulnerabilities that can hurt you than static does. So it's kind of like a brain flip, right, in terms of how you think about it. Again, there's open source tools, there's commercial tools, there's pen testing companies, however you get there. Make sure dynamic testing is part of your strategy for those high risk, high threat. So 3 great resources for you here to take home. So the first one is the developer topics around the security. Read the first page. The first page is Google's 10 things you should be doing, and then there's link offs to everything there. In the examples we gave here, you noticed every single example had a link somewhere in the security pages inside of Google, so they're there. Security's not a cakewalk, but there's a lot of ways you can incrementally improve your skill set by having a look at that. We have a 110-page secure development best practices guide. So this is taking all the Google stuff and wrapping it into, well, how should I look at the world as a developer, as well as our own experience. We encourage you to download that. It is a tome, and we are working on an update to it too, so you'll be downloading a version that's got a little bit of age to it. And if you really are inspired to learn a little bit more about security, we encourage you to have a look at this document from OWASP. OWASP is a non-vendor driven, independent standards body that was created by security professionals to really raise security standards, create common security language, and create a common understanding of threat and risk. And so we've been sponsoring and working with the AppSec group around mobile. There's a web group and there's a mobile group. And just late last year, we produced, or the OWASP organization produced a document that's really designed for application architects and developers. So what this will do is it will walk you through threat modeling. It will walk you through where risks are from a mobile perspective as compared to web perspective. And it can teach you a lot of the filling in all the elements that we talked about today. It is written more for developers than it is for security people. There are companion documents for security people. So if you want that sort of 150-page bedtime reading, it can be an interesting resource. Even if you don't read the whole thing, it's a great index. It's online. You can download it as PDF, and it's completely searchable. There are other resources up there as well. So we've got 2 guys that have seen thousands of apps. You're welcome to stop by our stand. We're looking up an app. If you've got an app in the App Store, we can give you a quick scan and dynamically, and you show you what's going on in it, take it home with you, and take some work on that. And feel free to ask these guys questions as well. We've been coming to the droidCons really as a way to help sort of share knowledge around security. If you're interested in a copy of this talk, you can ping me on email. So I will be sending out a copy tomorrow to anybody who sends me an email. You can also follow our Twitter account. We're always posting security best practices and things like that. And we hope you found this useful. All right, thank you very much for coming. And we'll be around in the back there for more questions.